Question 4, we've got some data about elements bromine and magnesium. We've got melting points and boiling points. Explain in terms of structure and bonding why the boiling point of bromine is different from that of magnesium. If we have a look at it, it's a lot lower, so bromine's a lot lower in terms of melting point and boiling point. And in terms of the difference, we've got a sort of difference of about 66 degrees here, and we've got a much larger difference of over 400 degrees here. So that's something else to note, that there's differences between the melting point and boiling point. Magnesium, it sort of stays a liquid for a lot longer, over a longer temperature range, over a larger temperature range before it starts to boil. So let's have a look then. Bromine is, first of all, bromine is Br2. So what bromine does, Br2, Br atom is in group 7 of the periodic table, wants to gain an electron. So they pair up in twos, Br2. They each put an electron in each into the covalent bond and fill their outer shell. So Br2 with a covalent bond between two Br atoms. And then each Br, so it's molecular. Molecular means that it's just a small number of atoms covalently bonded together. So Br2 is just two atoms covalently bonded together. Now, that's going to have a very low boiling point and a low melting point because there's no electronegativity, so there's no polar bonds, no dipole-dipole attractions, there's no hydrogen bonds, there's no oxygen bonded to a hydrogen or nitrogen bonded to a hydrogen or fluorine bonded to a hydrogen. So it's just van der Waals forces which are weak, and that is why it's got a low boiling point. Magnesium, incidentally, magnesium is a metal, so it's got metallic bonding. So what that means is the atoms lose electrons and form plus ions, and the electrons are delocalized. They move between the metal. It's also a reason why it conducts electricity, the moving electrons. But the moving electrons then are delocalized, and the ions, the plus magnesium ions, bond to the minus delocalized electrons which are moving through the metal, and that's called metallic bonding. It's quite strong, actually, metallic bonding. Not as strong as something like ionic bonding, but it's quite strong. So it's going to have a relatively high melting point and boiling point. So Br has weak van der Waals forces between the molecules, so more energy is needed to overcome the stronger metallic bonds. So you could say that less energy is needed to overcome the van der Waals bonds than the metallic bonds. And finally here, the magnesium for the 5th mark is to talk about this range. So magnesium has a greater range. It's a liquid for a longer temperature range. See, it's a liquid when it melts and then starts to boil. That's a large temperature range. It's a liquid for a long time over a large range of temperatures, and that's because in the liquid metal the force of attraction and metallic bonds are still strong. They're strong in a liquid metal.